Hey, now I'm going to be talking about stars. Now, stars come in all different shapes. Well, not shapes, they're all spheres. I was going to say shapes and sizes, but now that I think of that, never mind. Um, so, a lot of people, their big saying is that our sun is a middle sized star. That's a misnomer. I mean, it's right, but not really. So, if you were to take the smallest star and the biggest star, it's true the sun would be sort of in the middle. But those small stars account for 80% of all the stars in the universe, whereas the larger stars account only for like less than a percent. So the sun is actually more of a rarer star since it's larger, about 8 times larger than those small stars, brown dwarfs, and then you have sort of red, which don't actually emit light. Then you have red dwarfs, which emit tiny amounts of light. Then our sun, which is a yellow dwarf, and then or yellow, yeah, yellow dwarf. Then you have red supergiants, which are stars that are just big, and then supergiants and hypergiants and all that other stuff. Uh, but you can have special types of stars. First one, or how do I say? Combinations, I guess I would say. But what I'm trying to say is binary stars. So a binary star system is two stars that are orbiting each other. They have just a common center of mass because not orbiting each other. They're orbiting a point in the middle, which is the average of their gravitational centers. So they're orbiting like this, as you can see. That's a horrible. Yeah. Anyway, you probably get the point. Uh, and when they do this, the binary star systems are actually quite common. A lot of big stars, Sirius, which is the brightest star in the night sky, is a binary star system, Sirius A and Sirius B. Um, the nearest star system to us is actually a trinary star system because it's three. It's um, Centauri A, Centauri B, and Proxima Centauri, which is pretty cool. Then you also have variable stars, which are stars that basically vary in brightness. Sometimes they're dimmer, sometimes they're brighter. If you saw the Betelgeuse thing a while back, where Betelgeuse was like, "Oh, it's getting fainter," that's because Betelgeuse is a variable star, and it changes brightness over time. Uh, some do this in cycles. Some do this somewhat spontaneously. With the Betelgeuse thing happened, it has two main cycles, and it just happened to be dimming in both of those cycles at the same time, which was sort of just a rarity, but pretty interesting. Um, and then the white dwarfs are really interesting because white dwarfs are basically corpses of stars. Basically, when a star dies, its core becomes a white dwarf, which is basically sort of a star that is dead, but it still gives off light, but it's basically dead. It can't give enough heat for anything. Um, Now, some white dwarfs are what's called pulsars. Now, pulsars are interesting because they emit massive pulses of electromagnetic jets, which basically, and they rotate extremely fast, millions of times a second. But they do it in a very particular pattern, like very on the dot, uh, almost like a clock, tick tock, So they are very extreme, but they're also very interesting because they're sort of their tick changes over time, um, and you can sort of use that to do a lot of other things with distances between stars and stuff. So there's also another type of pulsar called a magnetar, which has a magnetic field billions of times, as strong as Earth and stuff like that. But most of the stars are, just there's also a stellar classification, any jump canon with the I think it's O and M and A and B stars, and that just talks about how hot they are, and then the other scale is uh, sorry, their size. God, sometimes. But yeah, with that's basically stars. Yeah, I don't know how to end this.